My name is Aditya. I work for Microsoft, and I mainly deal with SQL Server on Azure virtual machines. I have been in this industry for quite a lot of while. I think I might know SQL Server and Azure a little bit, and I would try to help you folks to understand how to configure SQL servers and on Azure virtual machines in a best way, such that you get both the price, you get the perfect perf for the price that you're actually paying. Okay, that's the deal that we are going to do. So before I get started, tell me how many of you are already on Azure? Raise hands. Okay. How many are thinking to be in Azure? Okay, that's cool. So if you know, if you go into Azure, right, you have lots of options. Like you have PaaS. In PaaS, you have MI, SQL DB, and also you have IaaS, which is infrastructure as a service, correct? Where you can run your own SQL server, the same SQL server that you have on-prem, and put it into the virtual machine and make it work. So by far, what we have seen is this is one of the most popular options. Why? People kind of look at this in a way where they want to have a control on the things that they are running before they really go to PaaS. And they think this as a lift and shift, right? So first, initially, you are on-prem. You will go to VM, deploy in the VM, and you see how it is working with the Azure. Then they will go to PaaS. We have seen these kind of things with the customers with the Azure. Now, coming to the options that we have when you are running your SQL Server workloads in Azure, what options we have? We have multiple options. But if you go and look at Azure, right, go type in Bing or ChatGPT, ask ChatGPT, or go type in Google and say, hey, give me Azure VM options, you'll get all these options. You will see entry-level VMs, you will see B series, you will see E series, you will see D series. There are a lot of options. But because you're here, and this is the session where I will try to help you folks, what is the right VM you need to pick for the better performance that to be run on SQL Server, so in Azure. So we as a team, what we generally do is we work closely with the Azure compute team, and we understand what is the type of VM that SQL Server should be running, and we kind of work with them to design such kind of VMs. But in all, what we see is the memory optimized VMs are the better VMs that we really prefer you to run your SQL Server workloads. The reason is, any guesses why I have asked for memory optimized? Any guess? Quick guesses? The answer is simple. SQL Server is a memory eater, as in it requires a lot of memory, and how much ever memory you give, how much data you have on the on-prem, it can take and put it into the memory. And if it is in the memory, it will perform better. Hence, what we say is go put your SQL servers in memory optimized SQL servers, VMs. And if you say, but dude, I don't have that big workload, I'll run a small shop, and I don't want a very big memory optimized VM. Sure, you can start with general purpose and confidential computing VMs. And in this memory optimized VMs, there is this EADS and Ebdsv5 VMs, which we really prefer you to run. So I don't know how many of you seriously follow SQL Server in day and day out. If you follow the community, my manager is very, very famous. Her name is Pamela Hood, and she is famous for saying double sprinkles, and the reason why she says double sprinkles is on the VM Ebdsv5. Why? We will talk about why Ebdsv5, okay? Now, I will try to explain you what is this all about. What is what is E, what is B, what is D. There are so many naming conventions out there, and as a data person who is running SQL Server, what I really need to care about. First of all, this naming convention has a thing about it. There is a family and a subfamily. There is a family as in, if you are running on E is a family, M is a family, D is a family. And the letters, each and every letters that you have, Ebdsv5, each and every letter has a meaning attached to it. As in, if you are in the B word that follows is the VM which has greater bandwidth, okay? If you have a VM with D word in it, that means it has the local disk attached to it. And if a VM that has I word in it, it is the VM which has the isolated size in it. And L has low memory, M has memory intensive, all that. But Aditya, tell me what is the thing that I need to concentrate? You give me a lot of words. Tell me the thing that matters to me as running SQL Server in the VM. I'll say concentrate on these two words, B and D. If you see a VM which has these two words in it, two letters in it, B and D, we would go ahead and say, go pick that VM. Why? That means it is the VM which has the local disk, where we want you to keep your TempDB, and it is the VM which has got the greater bandwidth to the remote VM, to the remote storage, sorry. So make sure that you have B and D, okay? Now, there are other type of things that can happen, like I want a bandwidth of a 64-core VM, but I don't want to pay 64-core licenses. I only want to pay 32-core licenses. I want the bandwidth of 64-core, but I want to pay only 32-core licenses. In that case, you also can go to, there is an option called constrained core VMs, where you can say, I would take a 64-core VM bandwidth, but I pay only 32-core, that is E32_64-core VM. Those are constrained core VM options. If you are a shop where you are really caring about that factor of licensing and everything, we ask you to go ahead and check out the constrained core VMs. Okay? Now, let's talk about the basics again. This is the Azure Virtual Machine Disk Provisioning. Before I say that, right, I will also tell you about few basics, right? If you are on-prem, the way it works is you have a SAN administrator who gives you storage. You have a server admin who gives you servers. You put your databases, you get your servers done, right? But when you're in Azure, when you're in cloud, you really need to take care of everything. And when you are taking care of everything, what exactly it means is, and it really doesn't work how it works in the on-prem. There are limits at VM level. There are limits at disk level. And there are limits at each and every disk level. And there are different types of disks, different types of VMs, right? So in here, there are 3 levels, right? First is disk levels. If you see, there are unmanaged disk, cache disk, and local TempDB disk. These are the plain disks, right? What is a unmanaged, uncached managed disk? It is pure remote storage. If your data is in the remote storage, that is unmanaged cache disk. If you are, uncached managed disk. There is something called cached managed disk. What's a cached managed disk? I will come to that, but before that, what you might need to understand is, in Azure, there is this concept called host caching. If you have a VM, and if you have a host, and that host has a local disk, that local disk can serve you as caching also, which gives you more performance. And if you enable that caching, the first hit will go to the cache first, and then goes to the remote storage. I can explain to you, it might sound Greek right now. If I go into the graphics later, you will understand it more. But all I want you to know is there are different types of limits that are there for each and every VM. So let's talk about each one, right? If you go open the docs or the learn.microsoft.com, and if you go and look at each and every VM and their limits, this is what it starts with. First one you see is max uncached disk throughput. That is the VM network level provisioning. What exactly it means is, for every VM, we say that this VM can go only till 38,500 IOPS. That's the max this VM can go till. So that is the max of uncached disk throughput. And the second part is temp storage. This is the size of the temporary disk, that ephemeral storage that every VM has. And this is the max temp storage throughput. This is the throughput for that temp storage. Right? Understood? So every VM has a local disk attached to it. For that local disk, there is a throughput. And there is also a throughput for the VM also. This is the throughput for that local disk that is attached. Make sense? Are we clear? Yeah? Now, let's really see it in a wholesome, right? I told you the entire thing is 38,000 IOPS, and the 5,000 IOPS is for the uncached managed disk, and there is also cached managed disk with 5,000 IOPS. Let's really break this down, right? If you see max temp storage throughput out there, IOPS/Mbps, that's the 38,000 that we are talking about, because this is coming to the local disk. Whereas max uncached disk is the total thing that can go to the remote storage. Okay? This is the remote storage. This is the local storage. These are the disk storage, as in every disk has P30, P20, P10. There are different type of disks. For each disk, there is a certain limit of IOPS and throughput. So for a P30 disk, the max IOPS that you can go is 5,000. Max throughput you can go is 250. For this entire VM, which is E8DSv5, the maximum IOPS that you can go is 12,800. And the local disk has 38,000 IOPS. Now, Aditya, you have given us a lot of numbers now. There is 5,000, there is 38,000, there is 12,500. How can I make sense of all of this? Let's talk about that. I'm here to explain each and everything in detail, such that you folks go out of this room understanding this diagram. Now, choosing the right VM size. How should I choose the right VM in Azure? The way you choose the right VM in Azure is by actually measuring it. You take your on-prem workload. You need to see what is your throughput of that workload, what is the latency of the workload, what is the IOPS of that workload. The IOPS of the workload will be coming from the perf counters such as disk reads per second and disk writes per second. The throughput of the workload will be coming from disk read bytes per second, disk write bytes per second. And the latency is the average disk seconds per read and average disk seconds per write. If you, in your workload, let's say you have an on-prem workload, and if you take these counters over a while, as in when it is so busy, let's say at 9 a.m. your shop opens, so many transactions come at that point of time, you should have a performance running at that point of time, knowing all this. When it is not busy, what is the workload looking like? When you have jobs, like OLEP jobs running, what is the type of workload and how much performance, how many disk reads per second, disk writes per second you are doing. You might need to understand for each and every type of workload, you might need to understand this. And then by taking this, you need to take these and account this for the things that I have told you previously. What is the type of disk that I need to take? What is the type of VM I need to select? et cetera, et cetera. So these are the things that you might need to measure. Now I told you many things, right? But if you ask me, okay, please stop it. Tell me one thing, one golden rule. Tell me one VM that I really need to choose. If you ask me that, from the product team who have seen so many customers, we say, pick this VM, period. If you are in doubt, go pick this VM. Why? We have done a lot of research, and we have compared the workloads with AWS, with GCP, with every other cloud provider, and we have done so many benchmarks and said, okay, if our customers who have higher number of transactions, they should be running in this kind of VM. If you ask me why, this is the VM where we have got very good core to memory ratio. This is the VM where we have got extremely very good throughput for that VM. So when in doubt, please go ahead and pick Ebdsv5 VM series. So now, the recommended VM series is Ebdsv5 VM series. But if you say, in Ebdsv5 also, there is a max limit that you can go. You can only go till 96 cores. But if you have a necessity of going more than 96 cores, then you have to pick M series. Because M series is one of the largest VMs that we have, where we can go till 128 cores. So M series is one of the biggest VMs that we have. And if you are entry level and you don't really have that big workloads to run, then go ahead and pick the D series. D series are one of the best VMs for the entry level. But always we recommend Ebdsv5 VM series for SQL Server workloads on Azure. Okay? So as I said, once again, when in doubt, pick Ebdsv5. So this is a golden rule for every workload that has to run on Azure. Cool? Make sense? Now, there are few customers who came to us and said, even in Ebdsv5, we really need more amount of IOPS. Then this one is in the preview right now. We are coming up with 260,000 IOPS and 8,000 Mbps VMs with the Ebdsv5 new series. And this one comes with NVMe disks attached to it. This is right now in private preview, I guess. And this is in public preview. If anyone is interested of getting more than 120,000 IOPS, which means you want to go till 260,000 IOPS, and you have a greater workload, please go sign up here, or please come talk to me. I can help you, get you this link, introduce you to people and you can get to sign up to such VMs. This is one of the top class VMs Azure has ever provided. Okay? Cool? Now, all is good. We came to a stage where we know what is the VM that we have to pick. It is Ebdsv5. Okay? We all agree? Yes? Yes? Yeah, okay, cool. So in this, now, once we pick VM, what else we need to pick? We need to pick storage, right? The second is storage. Let's pick storage. There are multiple types of storage that Azure provides. They provide standard disk, they provide premium disk, and they provide ultra disk. And recently, we also introduced a new type of disk called Premium SSD V2 disks. What are all these disks? Why are there? And all that is, each disk comes up with its own number of IOPS and throughput. If you pick a premium SSD comes from P10, P20, P30, P40, etc. A P30 disk, if you pick P30 disks, for example, comes with 5,000 IOPS and 250 Mbps. Whereas Ultra disk is extremely costly, and it can go till 160,000 IOPS. But we as a team worked with Azure Compute, Azure Storage, and we came up with a middle ground called Premium SSD V2. This VM, this particular disk can go till 80,000 IOPS, and it also can go till 1200 megabytes per second. Whereas first 3,000 IOPS are free for the customers. What exactly this means is the ideal choice of storage is Premium SSD V2. If and only if you are picking Ebdsv5. If you pick Ebdsv5 and Premium SSD V2, that's the gold standard combination of running a SQL Server workload on an Azure VM. Now, as I said, each and every disk type has its own way of configurations. As I said, Premium SSD comes in these all different formats: P30s, P40s, P50s, P60s, P70, P80, etc. If you see, P30 essentially have a maximum number of IOPS of 5,000, and P40 a maximum number of IOPS of 7,500. And it can only go till 2 terabytes, a P40. Whereas if you take a Premium SSD V2, you can configure from 1 gigabytes to 64 terabytes, and you can configure IOPS from 3,000 to 80,000. It is dynamically scalable, where the Premium SSD V2s. Whereas Premium SSDs are only scalable. You only can pick either P30 with so-and-so IOPS or P40 with so-and-so IOPS. You can't change them. Those are fixed. Okay? Now, as I said, there is one more type called Ultra Disk. This one can go till 160,000 IOPS, but I generally don't recommend this to the customers because these are extremely costly. But this really offers sub-millisecond latency for the workloads. Now, for Premium SSD V2, it comes up, as I said, you can have the first 3,000 IOPS as free, and you can go till 80,000 IOPS. The way it calculates is it has a formula called either you can pick a maximum of the minimum IOPS that you can pick is 3,000, or you can go for every 500 IOPS or for every 500 GB, we will add 3,000 IOPS automatically. So that's what it actually comes up with. Now, hence, if you combine both Premium SSD V2 and Ebdsv5, we have done a lot of tests with companies like GigaOM and others. And what we saw is the price perf ratio you get by combining Ebdsv5 and Premium SSD V2 is $1.53 for every 1,000 new orders per minute. This is a benchmark that we have got, and when we ran this benchmark, we are confident. We have also did a benchmark against AWS Best VM, and we also beat them by a good ratio. And now we can clearly say with these two, Ebdsv5 and Premium SSD V2, we can confidently say Azure has got the best price perf to run SQL Server on any virtual machine. Cool? Now, we spoke about I/O capping, right? So I have shown you a diagram where it has 5,000 uncached, max cached, and everything. Now, till now what we discussed is we know the best VM that we can pick is Ebdsv5. We know the best storage we can pick, that's the Premium SSD V2. But how it all works, like internally, how an I/O works, what is the caching works, all that is very important to understand. And also one more thing, that is Premium SSD essentially comes with host caching, whereas Premium SSD V2 doesn't come with host caching. host caching is disabled in Premium SSD v2. Now, how it actually works? Let's look at it, right? So let's say you have a SQL Server, okay? And you have 10,000 IOPS in this SQL Server. Now, you picked 3 disks. One is P10, all 3 P10 disks. Essentially, what you want is, you think, essentially we expect, this 4,500 IOPS goes to disk 2, 4,500 IOPS goes to disk 3, and 1,000 IOPS goes to disk 1. This is what we expect, right? But what essentially happens is, only 500 IOPS comes out. The reason is, the maximum capacity of a P10 disk is only 500 IOPS. Even though you throw it 4,500 IOPS to it, the maximum that comes out of it is only 500, because that's the maximum capacity of a P10 disk, okay? So, which essentially means I only get 1,500. So I have tried to give 10,000 IOPS request, but I only got 1,500 IOPS back to me. Now, how to solve this problem, right? So the way to solve this problem is, okay, what is the bottleneck here? P10 disk. Let me change this P10 disk to P30 disk, where each disk has 5,000 IOPS, right? Let's see what happens if I change that. If I change that, I again try to give 1,000 IOPS, 4,500 IOPS, 4,500 IOPS. Because each and every disk has P30, and each and every P30 disk can go till 5,000, I can get the 10,000 IOPS back to my SQL Server. Because the maximum, you asked for 4,500 IOPS request, but the capacity of this disk is 5,000. I will get the 5,000 request, 4,500 back. Make sense? Cool? So what this essentially saying is, it is so important to understand what is the type of disk that I need to really pick. And this is all if you are in Premium SSD, not Premium SSD v2. Now, this is all disk level I/O capping. Let's see what is a VM level I/O capping is. Okay? Here, the scenario is, I have picked P30 disks, each of 5,000 IOPS capability, and I have the VM, which is the capability of 12,800 IOPS. Okay? Now, I'm trying to insert 15,000 IOPS. Let's see what happens. My VM only can get 12,800. I have the disks which can get 15,000. What happens if I give a 15,000 IOPS request to it? Ideally, it needs to go this way, give all the 5,000 to all these 3 disks. But what happens is, only 12,800 comes back, not the 15,000. Though the disks are coming back with 5,000 IOPS request, the VM only can manage to get only 12,800, because the capacity of that VM is only 12,800. Make sense? This is the VM level I/O capping. So Azure has both VM level I/O capping and disk level I/O capping. You really need to understand both of this and configure the VMs and the storage that way. Now, what we need to do is, you might need to understand these 2 factors very well, and then only you have to go ahead and configure your SQL Server VMs in Azure. Now, for this particular problem, this very, very particular problem of configuring P30 disks and P10 disks without Premium SSD v2, how to address that factor? That then comes host caching. That's what I was talking about to you folks previously, where what exactly host caching does is, there are these Premium SSD disks where you can say, set host caching on for the data disks. What happens then is, you can keep the D drive attached, you can use the IOPS that D drive has. So let's see what happens then. If you have a VM and you're having a cache to it, you send a read request. That read request goes to the uncached disk, which is the remote storage, and the read response comes back to the cache and goes to the VM. It exactly works like how a buffer pool works in SQL Server. You actually issue a IO request. It goes to the uncached disk, and then it stores back into the cache and gives back that request to the VM. Right? Now, when the data is available in the cache and you ask the same request, it won't go to the uncached disk. It will come back to only from the cache, because you already have given that to the cache. Cache actually got that request already. Now, what happens in the case of writes? You give a write operation, the write operation goes to the uncached disk. There is no change in the write operations. The only change is in the read operations. Now, let's take the same scenario. You have Ebdsv5. Now, I turned on host caching. I have got the 15,000 IOPS, but this host cache is 38,000. Now, let's push the 15,000 IOPS request that we have pushed previously. There also we have, the maximum IOPS that this VM can get is only 12,800, but here we are trying to get it 15,000 by introducing the host caching to it. Okay? I introduced 15,000. I have given 50,000 IOPS. It goes through the host cache. And because host caching is there, it uses the host cache and gives back the entire 15,000 IOPS back to the VM. Because we are using that in 38,000 IOPS also here. Not just the 5,000 plus 5,000 plus 5,000, 15,000, we are also using this host cache IOPS here. That's how you might need to use host caching. And this is only eligible, or this is only valid for Premium SSD. But for Premium SSD V2, the newer ones, you don't have host caching. You really need to manage that, because we generally it won't support host caching. But Premium SSD V2 essentially has 80,000 IOPS where you can go. So you need to be intelligent in selecting, hey, I have a requirement of host caching or not. You might need to decide and pick either Premium SSD or Premium SSD V2. Cool? Now that we know what is the host caching, what is Premium SSD, what is Premium SSD V2, all that, let me go ahead and tell you what are the best practices that you really need to do. As I said, the golden rule, when in doubt, please choose Ebdsv5 VMs. Ebdsv5 VMs are one of the best VMs that we have introduced in Azure. And when in doubt, please choose storage as Premium SSD V2. Because Premium SSD V2s are one of the best storage options that came out, where you can dynamically scale your IOPS whenever you want to. But if you have the options of, hey, I don't know my workload, and that workload might have a necessity of host caching, then please choose Premium SSDs. But if you ask me, Aditya, please don't confuse us. Tell us either V2 or V1. I will say V2. The reason why I say V2 is because by cost also, Premium SSD V2s are cheaper than Premium SSDs. So hence, it is always easier for you, both from price point of view and performance point of view, to choose Premium SSD V2s. Okay? Now, I also want to introduce one of the other things that comes when you are running SQL servers on Azure VMs. When you run SQL servers on Azure VMs, essentially, there are multiple ways of configuring these SQL servers on Azure VMs. One is go to Marketplace and just configure this. If you go to Marketplace, all the striping and things that you need to do manually will be done directly by Azure. We make sure that you get the proper advice, you get the proper IO sizes and everything when you create a SQL Server via Marketplace image. And we also have so many best practices embedded in Marketplace images, such as instant file initialization, lock pages in memory, optimize for ad hoc workloads. All of those are there in Marketplace images directly when you go ahead and configure. So I would personally, because I go and monitor, I go every day and make sure that these Marketplace images are good. So I know these are pretty good images. Please go ahead and use them such that you get the most performant SQL servers out there. And while we are at here and we have time, I also want to say, when you run SQL servers on Azure, you not only get this better price perf, we also make sure that you folks get very good manageability capabilities also for free. For example, automated backups, patching, automated patching, best practices analysis. All these you will get out of the box if you create a SQL Server virtual machine using Marketplace image. How do we get Aditya? Do we pay anything for it? No, you pay nothing. This is all for free. And how are you really making it enable? This is being enabled by a piece of software called SQL Server IaaS Agent Extension. SQL IaaS Agent Extension really helps you get all those features. And I'm sure all of you folks might have attended Bob Word's session, and you might have known that SQL Server 2022 has AID authentication, right? And enabling AID authentication in SQL Server VM will be extremely easy if you go ahead and get the SQL Server IaaS Agent Extension in Azure VM. It only takes one step to go ahead and configure. I can demo that possibly if time permits. So essentially, in all the words, it's your SQL Server. It's the same SQL Server that you have. It's whatever you are running on-prem. It's the same SQL Server you are running in cloud. Essentially, you really need to have all the better practices that you have on-prem, you need to have in cloud too. You need to have instant file initialization. You need to have lock pages in memory. You really need to make sure that your TempDB is on the local drive, your data files and log files are different, all that. So make sure that you are isolating your files, you choose the right VM, you choose the right disk. Whenever possible, if you're choosing Premium SSD, make sure you are enabling the host cache, all that. And don't enable host cache on the log files. Enable host caching only on the data files. Okay? So those are the better practices that you might need to use. And I have few references also for you folks if you want to go refer. And I will upload this deck into the SQL bit such that you can download that too. Okay? I'm open for questions. I see one question on the online. Should we disable host caching for SQL to make sure transactions remain durable and are returned to disk in the event of power failure? Not needed. Actually, that is not needed. So the question is, in the event of power failure, how host caching works? Host caching, we are not really saving anything in the host cache. It's exactly like a buffer pool. Like it's one another level of cache that you have. So you need not really disable host caching for SQL. That's not required. Okay, cool. Any other questions that I have? Yes, sir.
Last time I checked, Premium SSD version 2 wasn't available in the UK. Is that still?
Now it is generally available. Yeah. The question is Premium SSD V2 available in all the regions? It is slowly rolling out. Now it is available in UK. Yeah. Any other questions? Yes, sir.
Do you have the ability to change, now you're talking about automatic patching for VM,
Yeah.
both SQL
Yeah.
and the operating system, and do you have any ability to control when that happens?
That's a very good question. The question is, in automatic patching, do you have the ability to change when to apply those patches? So today, what we support is only the security patches, GDR patches for SQL and Windows. That's the only thing that is being supported. And you can say when you want that patches to apply. You have the ability. But if your question also is, hey, can I apply CUs also with it, cumulative updates also with it? Today, you can't. Can we do it tomorrow? We are working on it. We are working on getting you an experience where you can decide the particular schedule where you can apply CUs and security patches. Did I answer your question? Awesome. Any other questions? Do you have anything else? Okay. Yes, sir.
Just now you mentioned about the host cache should be none to the log, and then for the data you should enable.
Yeah.
Is it read only, or should I enable for read write?
Read only. So for data disk, you need to enable read-only host caching.
Okay, so what write should be just directly going.
Yeah.
Okay, yeah.
Awesome. Any other questions? Okay, cool. Then we don't have any other questions in online also, right? Cool. Awesome. Cool. I will stay around. And I really, really hope you had a great BITS. And thank you for staying long and attending the last session of the BITS. I hope you folks got some knowledge out of this. I'm really thrilled of you being great audience. Thank you so much. Thank you.